Welcome students. As I have promised that I will launch a series Physics in a GP for JEE Advanced. So as you know, discussing all topics for JEE Advanced is not feasible actually. And suppose if I make lectures on each topic, that won't help for JEE Advanced because there are questions, complicated questions, and many questions will be uh, based on mixed topics. So rather what I have done, some of the students have sent me requests to discuss some subtopic or the other, so I'll go for that. And if you see this video in YouTube, and in the comment box you can write about your request also. So the request sent to me was about discussing the path of a point on the circumference of a pure rolling ring. I mean pure rolling on ground. So the path will be a cycloid, and to calculate the length of a cycloid. So I'll go about that. देखो ये ground, and there is a pure rolling body, a ring, and let us consider a point P on the ring. After some time, see the velocity of the center C of the ring is this way, and the ring is having angular velocity this way. What is omega? It is v. If v is the speed of the center of this ring, v divided by r. What is r? The radius of the ring. So you have to find out the path of the, I mean, length of the path of the point P in one revolution, one complete revolution. So as you see, with time, next at a later time, the point P will shift here, it will shift here, and then it will shift here. So the point P will have such a path. ये होगा path point P का. And see, actually if you draw the ground, see the path followed by the point P is like this, na? It will keep on repeating itself. So this curve is known as cycloid. Now we have to find out the length of the cycloid. That means the length of the cycloid. See, ये है one revolution from this point. ये point से ये point पे आ गया one revolution में, and you have to find out this length. ये वाला length निकालना है. अच्छा, so let me take an intermediate point, say after time t. Say it starts at time 0. Now presently I am drawing time is equal to t, and the point P has shifted here, and say this is the center C. So how much angle has this? I mean the P this point was here at time 0, right? So at time 0 and earlier time, P was here, and as it rotates, or as it moves along, P has shifted from this point to this point. So in time t, that means the angle is omega times t. Okay, and that is the radius r. So this is the instantaneous axis, this point. I mean through this point passes the instantaneous axis of rotation, and to find the velocity of the point P at this moment, we have to join this line, this blue line, and perpendicular to the blue line is velocity of the point P, Vp equal to x omega. Let us write this length as x omega. Now what is x? You can find out x like this. So that's a triangle r and r, and omega times t. If you draw a perpendicular for so this length, it is r sine omega t by 2, right? So that's also equal. So x is equal to 2r sine omega t by 2. Now, so that is speed of the point P at this moment, at this time t. So what is the distance? So in one revolution, time taken, in one revolution, time taken equal to how much? 2 pi. So it will rotate 2 pi. Na? That means the point P, as it starts from here, it will move here. I mean, as it moves along, point P will return to this lowest position, right? So now the time taken is 2 pi by this angular speed omega. So now the distance, I mean the distance of the, I mean the point P distance covered by point P in one revolution. You see, that means the length of the cycloid L. So length of the cycloid is obviously integral Vp dt from 0 to the time 2 pi by omega. So let us substitute the values 2r, right? 2r integral sine omega t by 2 times dt from 0 to 2 pi by omega. So now length is equal to 2r now into 2 by omega, 2 by omega cosine omega t by 2, cosine omega t by 2 from 0 to 2 pi by omega. So there will be a minus sign. Okay, so now this is minus 4r by omega. I think there was this omega, x omega, right? Vp is equal to x omega. Yeah, so one omega was missing there. Omega, so this is this, so this omega will cancel, minus 4r times, or rather remove this minus, I will change the integration limits, cosine omega 2 by 2. So here you have 0, here you have 2 pi by omega. So that means length 4r cos 0 1 minus cos pi this minus 1. So you get 8r. That means the length of the cycloid is equal to 8r. Hope it satisfies your query. Thank you. Stay tuned for the next video.